everybody hear me back there? Good. All right, so I'm here from the Source Fire VRT. We're the guys that actually put out the snort rules that are what hopefully makes that engine useful. I'm here today to talk about something that sort of sprung from what we do with snort, but is a new product that I think a lot of people are going to be interested in moving forward. So what we're going to talk about today is kind of the security landscape of what is out there today. And I really want to thank Julia for just teeing this up perfectly for me, because her, talk about the complete insanity that is PDF files is really, one of the reasons that this project was born. File formats are made by crazy people, and that's something that, we're looking to address with this, because there's only so much you can do in IDS land to deal with, the million different layers of obfuscation out there. We're going to talk about what is the Razorback project, how it works, what the benefits of the system are, and then how you can get more information on the project. So, today in security is different from, where we stood 10 years ago, obviously. It used to be that, you had buffer overflows in servers, in well-defined protocols, and it was real straightforward to detect, some kind of an attack coming in because it adhered to a real strict format and was pretty straightforward. But today things have kind of shifted over to the client side of things because, the Microsofts and, other groups of the world that make all the big servers have kind of figured out the security game to a large extent and have locked those things down to a point where it's a lot easier to pick off desktop users than it is servers. When you get into that frame of mind, then you realize that there's a million different variations that you can use on any given exploit. There's infinite ways that you can put something together in JavaScript to obfuscate what you're doing. You can, split PDFs up across zip file comments. You can do, all sorts of HTML obfuscation. There's a million different ways to put something together, especially when you have intelligent people on the other side using tools that can be sort of abused in a million different ways. The other piece with client-side exploits is that they're very much delivery agnostic. With a server, protocol problem, it is real obvious that, this might be coming in on TCP port 80, and that was the only vector in to exploit that problem. But today you can drop something in over the web, you can send somebody an email that contains an attachment that owns them, you can, pop up on Google Chats and send them a link that, is going to own them. There's a million different ways that something can be delivered, as well as all the variations on the ways that you can actually hide the exploit itself. So that really, from a defender's perspective, makes things a great deal more difficult today than things were maybe 10 years ago. And just in terms of where the industry is in terms of defense products and defense processes, we have a number of products that look at data in a number of different ways, but each of those products has limited visibility at the end of the day. Your antivirus scanner on your email system, that's great for looking at email, but it's not helpful for drive-by web attacks. Your web proxy server, again, is great for web-based things, but if something comes in over P2P or email or whatever, that's not useful. Nothing does everything, but for good reason, frankly, because if you try to do everything and be everything to everyone, you're probably not going to do a good job of it at the end of the day. There is a limit also to the depth of inspection that you're dealing with. Particularly, you think about file documents. You might have 10K worth of a PDF that contains an exploit. Well, if you're an IDS, for example, you can't just spool up 10 megabytes worth of a PDF document in memory, wait for the whole thing to be reassembled, and then process it, because you've got to operate at wire speed. And you're not going to have happy users if their download of a PDF takes 10 minutes because you're waiting for the whole thing to come through and be analyzed, and they don't get it until that comes through. You also have disconnects between incident response guys and the guys who are making security policy and enforcing it. I'm sure that those people in any given organization are two distinct groups that don't necessarily like each other, let alone talk to each other. And there's only so much you can do with a lot of the tools out there these days. Snort is sort of distinct in that you can write your own custom rules for it. But antivirus, until ClamAV put out its latest release like a month or so ago, there was no antivirus product on the planet that allowed you to write custom signatures. So if you are sort of on the leading edge of defense and you know that you're a target for whatever reason, customizing things right now to deal with the threat that you're looking at is a difficult game at best. So, all of these things sort of led up to the creation of the Razorback project. And I'm going to tell you kind of what Razorback is, and then we'll talk about how it changes the model of security, today into something different moving forward. So essentially, Razorback is an open source detection framework created by the VRT. And when I say detection framework, I'm talking about not necessarily a single product that is going to try to solve all your problems at once, but something that helps coordinate response to attacks coming in from a variety of different mechanisms. It's something that will take all of the defense capabilities that you have right now and tie them together in a way that will become more useful to you, in creating a truly useful security posture. The other thing is that it is designed, and I'll go over this more as I talk about the system, to allow you to rapidly create detection for new things, especially if you're one of the folks dealing with real live APT and not marketing APT. Honestly, this project was born out of conversations with United States defense contractors, the guys who actually have targeted attacks coming in from China that legitimately looking to steal national security secrets, things of that nature. And it also is something that is going to allow you to actually do remediation across disparate systems that you might not necessarily be able to do today. So before Razorback and where we are now is you've got all these different products that are trying to protect you from things out on the internet, but they act independently of each other. You've got an email gateway that might filter out spam and check for viruses. You've got antivirus on the desktop. You've got a secure web gateway that'll recognize known threats and block those out. You've got your IPS, whether it be Snort hopefully or some other product. But these things don't talk to each other at all, and a number of them don't do full inspection of files coming in over the whatever internet mechanism in real time. So the point of Razorback is to bring these things together through a coordinated interface so that intelligence gained from one portion of the system can be related back to the others, detection automatically updated throughout your different products, and the whole thing tied together in a way that makes your organization more secure at the end of the day. So this is kind of just a quick overview of the concept of how the system works together, and I'm going to talk about what these different nugget pieces are and the routing system is in more detail here shortly. So let me sort of flip back and forth between these slides. Kind of the these are the key components of the system. The dispatcher, which is the central piece, that defense routing system there that you see in the middle, is the brain of Razorback, and it's responsible for routing information between all of the different nugget pieces that we call them of the system. It's essentially a giant database that sits in the middle of all these other pieces and tells the collectors, hey, I've seen this piece of data before. You don't need to pass it anywhere else, or oh, this is something new, let me pass it on to the detection side of the house. And coordinates logging output and things of that nature. You have data collection nuggets, which the concept behind this whole thing is that right now the reason that IDS, for example, can't do full file inspection is because of that whole issue of you have to do things in real time. You can't have network latency. Well, we're separating the collection of data on the one side from the detection of problems within that data on the other, so that you literally can have a collection nugget spool up that entire 10 megabyte PDF in its portion of the system, and when it's done grabbing the whole file, pass it on to the dispatcher in the middle of the system, and then send it on off to detection if necessary, in a offline fashion, so that you're not blocking users and not impeding the flow of network traffic to the people who need these things. So you have obviously, you have data collection on one side, you have detection on the other. Detection nuggets, it's a collection of different pieces of software that can either be threads on a single box or multiple physical boxes, depending upon the capacity that you want to to work with here, that are each specialized to do one type of detection. You might have a PDF nugget that will parse through PDF files and pull out all the component parts and look for anomalies in the file format. You could have a JavaScript nugget that looks for obfuscation techniques or exploits in JavaScript, things of that nature. But each of them are designed to be sort of modular detection pieces that can operate on a given data type. You've also got output nuggets, which are essentially custom routines to output data into whatever SIM you might have, or a web output format. It allows you to customize the way that you take the information that's gained from the system and put it back into whatever analysis platform you might have. And finally, we've got defense nuggets, which I had my picture earlier showing different systems updating each other. The concept here is that on detection of something from one of these detection nuggets, you can have a defense nugget program to go update your firewall, to go touch your ACLs, to add a signature to your IDS, or to your antivirus product, whatever that may be. This is chunks of software that are limited really only by what you can do programmatically to touch the different defense systems that you have out there. So let me give you kind of an example of how this is useful, and sort of a use case to make it a little bit less abstract. One of the things that you're dealing with today as an analyst is that attacks are coming in, heavily compressed, heavily obfuscated. It's difficult to pick out what you're interested in, what you're looking at, and there's a lot of legwork that has to be done to go from detection of something in an IDS, for example, and knowing what it is that you're actually dealing with and how you need to respond to that particular incident. And additionally, you can have, in a single document, you might have a whole number of suspicious activities. You have violations of the PDF file format that are interesting on one level, but you've got JavaScript obfuscation that shows somebody's trying to hide something on another level. And so you can have, this is designed to have multiple events, coming out of the system in the analysis module for a single attack, so that you know exactly what is going on in any particular attack. So this, the use case here is you're the security guy, but you work for a small company, so you're also the database guy, you're the system admin, and you're the IT support guy. So, when you're running some sort of IDS tool, maybe you've got a Barracuda box because it does all those things in one, and you get a cryptic alert about a PDF file that comes in from one of the users. Traditionally, you're going to see, maybe that came in over a gzip stream, and you just get gzip output of a packet that was decoded to find something wrong with the PDF. Not particularly useful to you. But with Razorback, it's going to go through and, on the detection side of things, perhaps Snort is doing the data collection. It'll un-gzip that stream. It'll find that PDF in there and pass it on to the dispatcher. The dispatcher will pass it to a PDF analysis nugget that breaks it all apart and does analysis on the PDF. Perhaps finds a chunk of JavaScript inside that PDF, passes it back to the system, which then passes it off to a JavaScript analysis nugget that goes through and deobfuscates whatever JavaScript payload may be in there, and sees, perhaps shellcode that could then be passed back into a libmu module that will analyze that shellcode and say, hey, it looks like this is trying to, do a connect back to China. And so, because the system is designed to go through and do this deep file inspection analysis, it provides all the output of what it has done back out to the user, so that all the work that is being done, all the analysis that's happening on these files, comes back out to the user. So, instead of just getting some sort of cryptic alert on a package that you might not necessarily even be able to decode on your own, you get a full view of everything that's wrong with this PDF. You know why the JavaScript is sketchy, and you have an idea of what that payload is trying to do at the end of that exploit. And so at that point, you can say, hey, instead of, maybe this was just a broken PDF file generated by some, PDF writer that wasn't really well implemented, or tried to be well implemented but couldn't follow a crazy spec, I'm just going to let it go. I don't have time to rebuild this workstation. You can say with certainty, holy crap, somebody just got owned. I better go into the box. So the other thing, that is useful here is you can do targeted forensics. We have different modules in the system that are tracking different, pieces of attack vectors. For example, email data. We're going ahead and pulling out all the header information and storing it off in the database. Capturing the body of an email and tracking, the names and the types of the attachments to a given email. Doing the same thing with URLs. We're looking at, which clients requested what files at what time, so that you can, take this data that might be useful if you run into a file that you later down the line determine was malicious. And because you're not just doing full network packet capture, for example, you can retain this kind of data for months and months and months, maybe years if you've got the capacity. And you can go ahead and in the future cross-reference that targeted forensic data to things you discover later in the future, so that you can use that to, if you find one system that's been owned, you can go back and see, oh, these 5 other systems also got emails from the same place with the same attachment name and the same type. Maybe I should check that too. Another use case here that we have as an example. So, Joe user, he's riding the subway to work, and he says, oh, cool, I found a thumb drive. And he brings it to work and plugs it in to see what's on it. And he says, oh, look, a PDF file. I wonder what's in this PDF file. Maybe he clicks it, and he opens it up. And, the antivirus system on the host, maybe it's been tied in as a data collection module with Razorback, goes ahead and sends that PDF off to the dispatcher. And that AV software, because, well, we've already seen that AV doesn't necessarily catch PDF exploits, it says, this file's fine. And, maybe the Razorback detection module doesn't find anything wrong with PDF either, because it's some kind of crazy ODE that nobody's ever thought of before. But, 5 days later, there's been a post to full disclosure, and somebody's talked about a horrible new, Acrobat memory corruption issue, and there's been updates to all the antivirus systems out there, and the next time this thing comes in, an antivirus system actually flags it because it's got, there's known copies of this ODE floating around, and the antivirus guys have got a string out of that PDF, and now this time they find it. Well, because Razorback has tracked the presence of that file coming into the dispatch system through, either email or web or AV or whatever, it knows that that particular file has been seen on several different systems within the organization. And at that point, the IT staff can go ahead and notify all the people who have opened that file on their systems, hey, crap, you've been owned and we didn't even know it, time to go bring you into your boxes. And in the meantime, an incident response team can go through and build a complete list of what may have happened in the days leading up to disclosure of that O-Day, just because this was being tracked, even though nobody knew there was a problem at the time. One of, I think, the most interesting pieces about this framework, though, is it's all about flexibility and customization. So, the whole idea for the project, like I said, came out of conversations with defense contractors. And these are the guys who are dealing with, for example, I was speaking to one actually a week ago back in the States, and they said, yeah, we found that there was a particular actor coming out of Russia, I believe in this case, who sent emails that had an attachment where the file name contained a whole bunch of spaces and then a .zip at the end. And apparently that was being rendered in such a way on whatever mail system that they used that the users didn't see it as an executable file. The system saw it as a zip file, and so users would double-click to open what they thought was a zip file, and instead it was an executable, and it went ahead and popped their machines. So, they're dealing with things that are not necessarily common, things that are not going to be in your standard antivirus signature portfolio or in your IDS signature portfolio for that. And so these guys need to take the information that they have and deploy detection for that rapidly so that they can, deal with whatever specific in-house app they've got. They can deal with the targeted attacks that are coming in against them, and deal with whatever their unique network needs are. Especially, governmental folks particularly have all sorts of kooky networks that do strange things that they can't talk to the public about, but they need to protect them. And so by having something that is highly customizable, they can go ahead and build detection that deals with, again, a variety of different input vectors, without having to go back out to the commercial world and request coverage for something that might tip their hand as knowing about this particular attack. So the way we built this system is, it's a series of modules on, the collection and detection side. And it's an open API. Right now, we have just a C interface, but we will very soon have Perl, Python, and Ruby, so that you don't have to worry about necessarily what language you want to write detection in. You can just sit down and write it without having to go do a refresher on C or whatever language you might need to. We've also designed into the database for the system, ways for people to, tag things and customize the database to meet their needs. There's, fields already built in for notes and other kind of, data tagging that might be useful. There's a whole field of flags that are just set for, you can flag things in whatever way it might be useful to you. We've got actually an entire table dedicated to, here, go ahead and set things up in here in whatever analytical way you want to. We don't know what your needs may be, so we're going to leave the framework open to allow you to do what you need to do. And of course, it's all right now in MySQL, so it's nice, it's open, it's flexible, you can do what you have to do. So a good example of where you might use this kind of customizability, again, is you've got your defense contractor being targeted by a real live APT group. And during an attack, one of the guys notices that the email senders are always spoofed to come from a U.S. company, but the content language field is something other than English, which I'm sure you guys can appreciate. Americans just speak English. So, with forensic information that's being captured already, we're already storing all these email headers we talked about earlier. The analyst goes ahead and sees a whole set of emails that match that criteria, to go back and review those and look at the body of those, and maybe they all contain a link to some spoofed website that has Ode sitting on the website. And then you can go ahead and actually write a quick detection nugget that will generate an alert anytime you see an email that comes in from that particular address that has a content language field other than English. While the incident response guys are off looking on workstations that got emails from this APT group, you can actually potentially trigger on some kind of Ode attack that no other system would find, simply because you've matched the behavioral profile of a particular actor who is targeting things on your system. The funny thing is, I talked about zip files with a number of spaces as an attack vector. I believe that this particular, the content language thing here was another real example from the wild. We've actually seen some groups find PDF Ode simply because the attacker forgot and left the author metadata field in the PDF the same every time, and they realized after getting owned with known attacks a couple of times, hey, wait, if we see this author field and it said that, you need to deny that PDF every single time. So this gives you kind of an example of the potential for the different kind of collection and detection nuggets that you could put out there. You could make routers and switches and servers and any variety of feed data into the system, as long as you can, put a piece of code that collects data from a given system. You can have it pass, data onto the defense routing system. Snort obviously already is we have a modification up on the Razorback website that you just patch Snort and it will automatically pass every packet it gets off to the dispatcher system. ClamAV, we have a module that will plug in and have it send all the files that it analyzes in. We have a Squid proxy server plugin so that you can send all web traffic that comes through your proxy in for analysis. And we even have a postmortem debugger so that anytime a file crashes, you can send in all the registers and what the file was and what the application was, and maybe you can spot Ode because somebody's careless and you'll see that EIP was 41414141. As far as detection nuggets, again, Snort actually does detection on its own, so we consider it a detection nugget as well as ClamAV. There's also a group called Dynamics has a really good PDF parser. It is unfortunately not open source, and it does cost a little bit of money, but it is worth the $500 in our experience, and it has an open API that ties in really well to our system. Office Cat, the Microsoft Office file format checker that Lorraine Grenier of our team wrote a few years back plugs in. We even have some JavaScript analysis nuggets that plug into the system. Perhaps the concept of gzip stream with a PDF that has flake compressed data that contains JavaScript that's obfuscated to contain shellcode might not work 100% right now, but that is exactly the kind of detection goal we're working towards now. Also, in terms of output nuggets, we alert into both standard Snort alerts, and we have an incident response alerting mechanism set up to go with our database. But you could easily tie this into your existing SIM. You could make it, send text messages if you are really crazy and want to get message at 3 in the morning. The concept really, though, is that anything you want to do, as long as you can program it up, you can do. In essence here, the key benefits of the system are that you take all the different security tools that you have today that are kind of operating in their own little silo mode, they're off in their own little corner of the security picture, and bring them all together so that they can sort of work in unison, and you can update one tool based upon the results of another. You can have really advanced deep file inspection that you can't do with a lot of tools today. especially at the IDS level. I mean, for us folks on the VRT that write the snort rules, there's always that sort of war between detection and performance in IDS land because you've got to operate at wire speed. And we always come down on the detection side because that's what we do. But when we were kind of told by a number of people who were interested in the system early on that, hey, we don't care if it takes you 15 minutes to do your analysis. We just want to be sure that something really is a true attack, and we want to know as much about that attack as possible. We all kind of, cheered for joy and said, holy crap, we can actually do all the detection we want to do. Again, you've got forensics capability that allows you to, get an idea of the behavior of systems that you might not have known were compromised. You can actually come back and say, hey, I've seen this particular attack come into this particular machine, and now I can go back and review based upon what's previously been stored in my targeted forensics to see that these other machines have been popped. We also have, I actually wrote a quick DNS parser that will dump off all your DNS queries off of any machine on your network. And so a good example might be that if you've seen a system get popped with a file that you didn't know was malicious at the time, you can go back and see that, okay, when it got hit 5 days ago, all of a sudden it started making DNS queries out to China, and you can use that as part of your incident response. You can now, update your firewall and say, hey, if you see a connection to any of these IPs, no go, because clearly they're, the command and control center for whatever botnet might be getting built. This, of course, accelerates your ability to deploy new defense capabilities because it is fully customizable, because you can do anything that you can do in any programming language. You're not, stuck waiting on a vendor to give you some capability. You're not tied into whatever update process somebody else has. If you've got a threat that you need to deal with now, you can just go ahead and program it up and deal with it yourself. Obviously this is sort of geared towards dealing with, the non-marketing advanced persistent threats, the guys that, if HD Moore was coming after your network, you might not even be able to stop him with this, but you can probably get a lot closer than you could with existing tools today. So, like I said at the start here, this is very much an open source project. A lot of people I know complain when the VRT took the snort rule set out of GPL land and made it into a commercial license. We're kind of making a strong point here that no, we're not just a bunch of greedy bastards. We do still like to give back to the community, so the whole thing is GPL. We actually have, we released the first functional version of the framework at DEF CON this year, and have got a pretty solid response from people who've seen it and have started to play with it. So we have folks outside of just the VRT making code commits already. It is very much under active development at this point. And so it's not, something that we're just going to put out there as a concept and then sort of let fester. While I wouldn't call this a magical silver bullet solution that you can just simply configure, make, install, and magically detect PT today, the underlying framework is functional, and we're, both making improvements to that kind of core portion of the system, as well as building detection and collection nuggets as rapidly as we can. So this is essentially where you want to go if you want to, get more information about the system. The labs.snort.org page will actually direct you over to SourceForge, where the whole project is being hosted. You can, I would strongly encourage you to go download it, play with it, deploy it on test bots, see what it can do, because every person that has actually started to play with it has, imagined new things that we hadn't thought of. People are very excited about the system, and so, we want you to go out and see what you can do. I think you've got the introductory questions here. I think we've got that concept handled here.
Well, I don't have that much, but I just kind of understand. You have these project collection nuggets, and you have commercial antivirus or something.
Right.
I noticed the only thing that was on there, like, that was antivirus, because you used an example of antivirus, it just doesn't plan anti-V.
Yeah, Calamity will do detection.
Somebody's
But, you know, honestly, those were just sort of examples. There are some commercial things that tie in right now simply because there were some easy commercial products to tie into, but by no means are you restricted to a commercial versus an open source product to do, you know, detection or collection. Honestly, the whole thing is designed to be completely program agnostic on both ends. As long as you can find a way to stream data into a little piece of code that calls into our APIs, you can put it through the system.
And what I actually like about it is that you can actually tie a lot of different antivirus products and run them simultaneously.
Yeah, that is definitely true.
That's why I'm asking, because do you see any attention for people that want to integrate different? I mean, what kind of rate of new nuggets for new products like detection products do you see? There's a lot of interest for this?
You know, well, in all honesty, this came out slightly over a month ago, and at this point, we're still sort of spreading the word. And a lot of the people who are most interested in the system to date are not telling us what they're doing with it, frankly, because, you know, Lockheed Martin is about to share their secret detection software with us, unfortunately.
Sure. Did I understand it correctly that, I mean, you have a sort of a central point that decides which data is going to be sent to what nugget or analyzed? So that would be a very strong point, I mean, a very important point to get things right. I mean, you have to know which data to send where.
Yeah.
It basically has to know everything about what the different nuggets can actually detect.
Yeah, so the concept essentially is that each of the data collection nuggets will declare the type of data that they collect, whether it be SMTP or executable files or, you know, whatever data. And then the analysis nuggets will register themselves as, hey, I deal with PDFs, I deal with HTML, I deal with whatever type of data. And so the dispatcher system is there to first, you know, have a cache of have I seen this based upon MD5, URL, whatever, other tracking vectors, so that you're not re-inspecting the same stuff over and over again. But also to be able to take that data of a declared type and pass it to any nugget that says that it handles that type of data. And the cool thing about it too is, you know, you talk about being able to say run multiple antivirus products with this. That's one way to do it. But you could also have, you know, maybe if you've got that Dynamics PDF parser, but you've also written a PDF heuristics nugget on your own. You know, these are strange things that might crop up in PDFs that I want to pay attention to. The system would actually send any PDF that it receives to both of those nuggets simultaneously, so you can have sort of multiple levels of detection on any given data type.
Right. So if I give you an example, let's say I have a detection nugget that wants to analyze all PE32 files,
Sure.
for instance. Now, do I have to declare what a PE32 file is, or is that something that somebody else has already declared for me?
Well, I think right now it's based on file magic for file types, which I suppose we're going to have to take a look. Yes, I see you raising your hand. You're totally right. You've done something that I hadn't even thought about. But essentially you're working with standard sort of data types, and so PE32 is standard enough. You're not going to have to go to the trouble of declaring what that kind of file is yourself. You just say, hey, I deal with 32-bit executables. Right.
Because you might want to build a detector or analyze a certain type of file that is not known to be an arbitrary new
well,
type of file.
Because the database is open and the database has the information on what types of data you're examining, if you needed to put a custom definition in there, you can do that through SQL calls. And realistically too, if you've got some type of data that you want to inspect, you need to declare on your own. If it's something that would be useful to anybody besides yourself, then let us know, and we'll just patch the main product to actually know what that type of data is.
And it would be nice if the nugget itself could tell what the definition is
to
the system. So it's a plug and play thing.
Yeah, I mean, well, to be perfectly honest with you, get on the mailing list and suggest things.
All right.
You know, we're still very early in the development phase here. We have something that functions, it scales reasonably well from our testing, but we have not by any means thought of every feature that can be plugged into this thing. So
it actually sounds cool. Great, kind of interesting. Questions from the audience?
You're going to be parsing a lot of data there.
Yeah.
We have thought about not getting on by doing that. So.
Well, you know, I guess what you're saying about, you know, getting owned by parsing so much data is the issue of scalability. Is that kind of where you're coming from? You know, how is this going to be able to keep up with the amount of data that you got to analyze?
No, more that if you parse a lot of data, there's
yeah, well,
that you have some error in the code.
Okay, that's a fair point. You know, I guess the only thing I can say to that is that any product or, you know, or any piece of code that does inspection of file types could potentially have ownage in its, you know, in itself. I mean, Snort has had, you know, a buffer overflow or two in its day. No product is perfect, but since, you know, we're designing this to be as open as possible, and you know, hopefully a lot of the detection nuggets are going to be open source. Well, you know, it's the same as with any other open source product. Let's have the community go out and check for problems. You know, at the same time, and, you know, as our first presenter, whose name unfortunately is escaping me now, you know, noted, hopefully if you're a security software creator and you're designing things to look for security bugs, you're smart enough to actually write secure code yourself. I mean, nothing is guaranteed, obviously, but, you know, because you obviously, as the person deploying the system, would have control over what detection nuggets you're running, it would be a matter of which ones do you trust.
Yeah, I was thinking about something like isolating the problem so it can't escape out and attack other things.
Yeah, well, I mean, it's all, you know, all of the detection stuff is running in user mode, unprivileged lands, and, you know, theoretically, if you had a large scale deployment, you might have, you know, multiple boxes dedicated to detection. So if you pop one box, you haven't popped the entire framework. You know, I'm sure that there are security considerations that probably ought to be reviewed. I know that the people who, you know, put this all together, you know, I did minimal coding on the core framework itself, but I know very closely the people who put it all together, and they had a lot of security considerations in mind. So, you know, again, if you're worried about that kind of thing, go download it and read the code. Let us know if there's any problems. You know, it's open source.
Okay, the reply.
Regarding the last question, there's, I think, mainly two things you can do to try to avoid this. One is like using a language where exploitation is difficult, for example, C# or something like that, for the parsing code. And the other thing you can do is like putting it in a compartment, putting it in a virtual environment where you have no access to the outside world, where you can just put in files or streams or whatever, scan it in there, get out the result via a serial line or something like that, and you're fine.
Serial line, oh, okay.
Take virtual machines with a serial line for getting like the response of the AV or something like that.
Yeah, well, I mean, honestly, you know, I think that the delivery of the output mechanism should happen over TCP/IP, and it will still be fine. But point taken, you know, doing it in some kind of sandbox is one way to ensure an additional level of security. And you know, because, like I said, we'll have APIs for like Perl, Python, Ruby. It's really hard to accidentally own yourself in Perl. So, you know, I think that is not necessarily at the forefront of our thought process, but it's not completely critical.
Or just write more stuff in Java. Right, any more questions?
Would you say that this framework would be suitable to control internal data flows in the sense of, for instance, if you want to make sure that your annual report doesn't leak before release date, Would you say that this is a suitable application for the framework?
You know, I would say yes, that, you know, conceptually that would work well because, you know, if you have enough data collection mechanisms to look at all the potential output vectors, you've got something that will trap files going over HTTP and email and, you know, P2P apps or whatever, and you've got the exit vectors covered and got, you know, metadata being pulled out of those for documents. So, you know, if any data collector is identifying, you know, all the documents, obviously, so they can be passed on to detection later on, then you could, you know, write alerting based upon the name of the documents or have a detection nugget that looks for certain strings in the document that you know are going to be in that annual report or whatever. So, I mean, it would potentially take a little bit of custom coding on the detection end, but yeah, I'd say that would be perfectly suitably used for this kind of thing.
All right, if there are no more questions, I just want to thank Alex.